This conference will now be recorded.
Good morning, everyone, and good evening, as per your time zone. This is Roshan, and I'm here with one of the demo sessions on cloud performance engineering in DevOps. Good morning. Yeah, thank you. So let's get started with our the agenda of this discussion. This is something about me. I have around 14 to 15 years of experience in IT, mostly predominantly into performance engineering, Java and Python development. On the cloud side, I'm also architect associate, cloud professional, AWS architect associate, and I've been also involved in automation using various technology like Java, Python, Terraform, Ansible, PL SQL, shell scripting, and Selenium. I'm currently working as a SRE engineer and a performance engineering and DevOps professional. Okay, principal performance engineer. Okay, so this is something about me, and this will be the agenda of our discussion today. We'll start with a question. We'll understand software development and deployment evolution, how software has been evolved over the period of time, and we'll go over the course syllabus, the cloud performance engineering and DevOps, and we'll set the expectations, and you will know more about the course, and we'll get the opportunity to get your doubts cleared if you have, and then we'll understand what will I learn by end of this course, what will be uh, the takeaway from this course. We'll understand that and with questionnaires. So the first questions, okay, the first question is, and in this, during this session, if you have any doubt, you can ping me in the meeting, go to meeting. I have that chat window open in my other screen, so I can look into your questions, okay, and feedback. Okay, so let's start with a question. So if I ask you, so how are performance engineers expected to know this? Okay, DevOps, microservices, containers, and cloud. Are performance engineers expected to know this DevOps, microservices, containers, and cloud? What will be your answer? Do we need to know this? Performance testers, engineers, uh, where do these things sit in the software development and evolution, deployment evolution? We'll get to that. So that's the first question we should ask ourselves, and the clarity will be done from the next slide which I have. If you look at the software development and deployment evolution, how software has been developed and deployed over the period of time, we'll understand where this DevOps, where this microservices, where these containers and clouds fit in. So if we talk about DevOps, so what is DevOps? So earlier when the software development started, we started with waterfall methodology, right? Everyone was doing waterfall. All software were developed all at once, and then we started to test and different phases carry on. We understood its demerits, disadvantages of waterfall. We shifted to agile. We migrated to agile. We adopted agile methodology, and where the software development was then in sprints, different sprints. So here, all the software develop, all the application software was developed at once, and then it went to the testing stage and other stages. But in the case of agile, we divided the software development into various phases. I would say we call those sprints in the agile. Again, so agile, it's not like we don't have issues here, we don't have problem here, because once the software is developed, it just takes a lot of time to get it deployed in production, and it is not that a smooth process. Once the developer completes writing the code, we have a lot of validations checks. The code has to get built, then it has to be tested. Automation engineer would test functionally, performance engineer, security testing, penetration testing, so many testing, and then only my code will be deployed in production. And all are manual activity, right? So the time to release the completed product, to release the product in production is and the difference between the software when the software get developed and the time to get it released in production, it's quite huge, it's quite significant, which is not good. I want my software to be deployed as and when my code is ready. I'm done with my code. Developers are done with the code. I want my code to be deployed in production as soon as possible. And that is the region I need to automate all the processes in between. Like once the developer completes writing its code, I need to automate the building of the code, the deploying the code in the testing environment automatically. There would be test suits, automation engineer, test suite. They would check the validation of the software for the functional aspect, right? And then there will be performance job as well, Jmeter or any other job which would check the performance of the application or the operated code. Security engineers would have their job for the security testing, penetration testing. If I can automate the entire process somehow, my my time to release, my time to get the product deployed in production would be quite fast. And that's the entire motion, the notion of the DevOps here. And we're trying to solve a problem from the agile, where the time was delayed, the time to release the product, deploy the product in production was quite delayed. So in the DevOps, we're trying to automate the entire process so that the software can be deployed swiftly in a very swift manner. And this is where this DevOps come into picture. So the industry is changing. People have understood the importance of DevOps, and we need to also upgrade ourselves. We need to also understand what happens in DevOps technology, what's our performance, how performance engineering fits in DevOps, how can we contribute to this DevOps. So we need to understand that as well, because that's how you understood waterfall agile, and now we are in the phase of DevOps, where we are trying to automate all the processes in between. Right. Again, coming to the microservices world here, we started with monolith application. Right. Monolith means where all the your business logic resided in the application server. We have taken a recent workshop on this, so I hope you guys have attended that. If not, you can ask Isha to for the recording. We have taken that in detail. The monolith application. What do we mean by monolith applications? And now we have understood the disadvantages of monolith and the more, I would say, the advantages of being in microservice architecture. And we have split the business logic and we have created microservices so that I can get high availability and the reliability of the application. Because one of the disadvantages of monolith is if one of the module goes down, let's say for one of the region, let's say I have a Flipkart app, I have various modules, right, in that app, module A, module B, module C, module D. And let's say I have writing functions there, logic, and one of the issues, one of the modules is not working because in the monolith architecture, the modules are tightly coupled, right? And because of that, because of one issue, the entire application can be down, and that's not good, right? It is a threat to application availability. There are other disadvantages as well, and that is why we have understood the importance of the application availability and how can we solve that problem. If we can if we can split that same business logic into various microservices, and I can make these microservices independent, right? And they can communicate with each other through lightweight REST API. Even if one of the microservices goes down, my entire application will not go down. To give you an example, let's say if I have an Uber app or a Swiggy app, let's say there's a functionality called notifications, right? Once you book a cab, you get a notification that you have booked a cab. Or once you order a food in Swiggy app, you get a notification that you have ordered a food. You get a notification bell, right? What if notification is not working? Notification is not working properly. Does it mean that you cannot book a cab or cannot order a food? You can still, the main functionality would still work because they are microservices. The entire functionality that you see in those applications are microservices based. Each functionality means one microservice. For notification, there is one microservice. For ordering, for login, there is a one microservice. For ordering a food or booking a cab, there is a one microservice. For payment, there is another microservices. And if when we combine all these microservices, they make up an application. And it is very much required. If you look at the application availability, for application availability and reliability, it's very important to adapt the microservices architecture, the way of development. Right? So again, we are in this stage. You must be hearing everyone is talking about Spring Boot and microservices. You must be testing mostly the microservice application, the REST API. Uh, Nowadays, if you're a performance tester or a functional tester, you must be testing uh, the REST API more nowadays. Microservices could be a REST API or a UI based application as well. It depends. So, and where do we run this microservices? The question is, where do we run these microservices? We run these microservices in containers, and that is where the resource is optimally utilized. Earlier, back in 1980s, whenever the software was developed, right, it has to be deployed on the server, right? We used to deploy a tiny little application, few KB, few MB application in a big physical server. This server have, let's say, assume the capacity as 100 vCPU and thousands of RAM. Let's say it has that much of capacity. And if we just install few KB MB application, do you think we are doing justice with the resource hardware configuration? No, right? We are wasting a lot of resource. And that is when back around in 2000 virtualization came, and we were able to create VMs. We installed a virtualization software on this physical server, and then we were able to create VMs, multiple VMs, uh, and we could host multiple applications in the same physical server because we created VMs. You guys must be, everyone is working in VM, right? We install, if you talk about server, when you call server, you basically mean the VM, the virtual machine, where you install your application server, your web server, and your database server, right? We install on the server itself. And when the virtualization came, we were able to host multiple applications now because we created VMs. And I can host one application in this VM. I can host another application in another VM, and so goes on. And now we are in the phase of containerization, where in one VM itself, I can create multiple containers and I can host multiple microservices. Basically, the idea has always been to utilize the resource better. That's the key idea. I want to utilize my hardware to its best possible case, right? I want to use my hardware in the best optimized way, at its possible, at most maximum its threshold. That's the idea of. And to get that, now we are into the microservices world, where we host our microservices in containers, and we do that by using container engine. On this VM, we install something called container engine, like Docker, a container engine. So Docker is a container engine. We install a container engine, and then we can create containers. And the containers will have your microservices. And I can keep on creating containers in one VM until I am fully utilized its resource. Once I have fully utilized its resource, then only I would go with the second virtual machine and I will create containers there. First of all, I will make sure that my VM is completely utilized, efficiently, optimally utilized, then only I will go with another VM to create further containers. In this way, I am able to utilize the resource better, okay, by using containerization. There is a, and once we have, so we as I mentioned, we need container engine to create containers. So container engine happens to be Docker, and there are other container engines as well, like Container D. We have Podman, we have Rocket, but Docker happens to be the most popular container engine. We'll talk about Docker. And again, it's not the end, because when you have a lot of containers, when you have a lot of microservices, you need to also orchestrate them, right? You need to auto scale. Once when the user load is growing, you need to auto scale the number of containers. You need to load balance the containers, the load coming in across all the VMs, across all the nodes. You need to load balance them, you need to deploy them. So you need to do basically orchestration. For those orchestration activity, I would use Kubernetes. There is a technology called Kubernetes, a container orchestration engine. So we use Kubernetes to orchestrate all those processes, so that once it is my container, my all the application is deployed in production, it will be highly available, reliable. Basically, to sum it up to layman terms, your application is not going to go down. That's the main objective. And Google from the last 15 years, they are using Kubernetes. Kubernetes is originated from Google. Google has invented Kubernetes. And who handles load better than Google? No one, right? And the way they write their logic, and they handle the load, no one can do that. And they have been, and Kubernetes is from Google. So you can understand this is a mature product, and that's why people are talking about Kubernetes nowadays. Everyone is talking about Kubernetes. Everyone is talking about microservices, and then they would have this CI/CD pipeline, the automated process in DevOps. Right? So that's the trend. That's the trend, and that's where we need to be. Coming to the cloud. Why are we talking about cloud? So cloud is not new, right? Cloud is not new for us. Earlier, when a company wanted to host their application, what they did, they had to create their own data center. Basically, they had to set up the complete data center. They will purchase all the. They will first invest in the land acquisition. They will build an infrastructure. They would purchase all the servers and all those operating system, everything they would purchase. Once they set up, then only they can host their application, right? That was the case back in 1980s. Again, 2000, this hosted servers came. There were few players who were giving you the hosting, and it was also there. But nowadays we are in the cloud phase. Why do we see new startups, more startups nowadays? Because the hardware, the compute, the resource is so easily available. It on rent. If we approach, let's say I'm coming, I have an idea and I'm trying to build an application. I don't need to think about data center cost, because data center is very costly thing. Setting up data center means you have to purchase land, you have to build an infrastructure, the building, you have to purchase all the servers, the operating system, everything you have to purchase, and it's a very costly affair. When you are in cloud, you don't have to purchase everything. You can simply contact a cloud service provider like AWS or Azure or GCP, Google Cloud Platform, that you would like to use their servers, and you will pay rent for that. So you can use their servers. They have set up data centers. They have set up data centers, and you are just going to use them, uh, and you're going to pay rent for them, for the servers that you consume. So that's why that's the phase we are in cloud, and that's what everyone is looking into nowadays. AWS, Azure, and GCP. They are relying on the cloud service providers to host their application. So coming back to the question, Our performance engineer expected to know this. Do we? So I hope we understood where these DevOps, microservices, containers, and cloud fit in. To understand that, we understood the development and deployment evolution, and that's where these four technologies fit in. And we are in this phase, current phase, and everyone is talking about cloud, microservices. Where do we host these microservices, and how can we make the deployment process smooth, fast, swift? How can we make sure once the developer is ready with the code, how would I deploy my code in production as soon as possible? That's the problem DevOps takes care of it by through automation. And that is where we are in this page. So I hope everyone understood the importance of DevOps, microservices, containers, and cloud. And this course, the one I'm coming up with, the Cloud Performance Engineering in DevOps, is based around these four things, completely around these four things that you need to understand. As part of the course, as part of the cloud, we are taking care of AWS. If anyone is new, and the course is designed from very scratch. So you don't need to have any prerequisite knowledge. If you are a developer or a performance tester or any field, you can take up this course. So I'm gonna talk about AWS here from very scratch. You don't need to have a prerequisite knowledge. You're gonna have one account and you're gonna practice there. So you'll get comfortable because you cannot do performance engineering once you do not understand. First, you need to understand the things. Basically, you need to be an administrator first to do performance engineering. That's the bottom line. We'll talk about AWS here. On the microservices, we'll understand what are microservices, the importance of it, the advantages, the disadvantages. Where do we run this microservices? The container engine, Docker, we'll understand Docker. Everything would be hands-on. We'll understand the Kubernetes, and at last we'll understand this DevOps, how this DevOps performance engineering fits in DevOps, and what all different activities that we supposed to perform. Okay, so that's the agenda here. That's the intention here to go about these things in this course so that you guys are comfortable working in your field. Coming to the syllabus, okay, we have cloud computing, AWS, Linux command line. That's what we are covering because if you are working with microservices, Docker, containers, Kubernetes, everything, you need to be comfortable with Linux, and that is where these microservices run optimally in Linux operating system. You need to be very much comfortable with Linux command line. When I say Linux command line, you guys are working mostly in Windows, right? Where you are very much comfortable in Windows. And in this course, we are going to target the same way. What tagline that we use? The tagline is get as comfortable in Linux as you are with Windows. That's the tagline we believe in, and we'll be taking everything from very scratch. So we'll cover Linux command line. We'll understand the software application architectures, the monolith, the microservices, those things. A container engine. What is container engine? Why do we need container engine? And Docker happens to be the most popular container engine. We'll understand that Docker architecture. How do we work with Docker? How do we create containers? How do we work everything Docker? What is Docker Compose? How do we create Docker images? There are so many things in that. Then container orchestration engine, Kubernetes, the most popular of all. I have not seen any interview where they don't ask about Kubernetes nowadays. Everyone is looking for containers, everyone is looking for cloud, everyone is looking for Kubernetes. Everyone thinks of, have you been participated in CI/CD pipeline? Because in the CI/CD pipeline, you're going to contribute by Jmeter job, your performance job. It could be a LoadRunner job. It could be any Gatling job. It could be Locust job. Anything you need to contribute there as well. Because CI/CD pipeline is at the organization level. Everyone would be involved there. A developer, test automation engineers, so performance testers, and we need to contribute to CI/CD pipeline by providing our job, so that we understand how do we create jobs. First of all, we need to understand, and we're going to cover Jenkins here. We're going to talk about Jenkins, and we'll understand that. And and most importantly, we need to understand where this performance engineering fits in DevOps. So that's the course syllabus, okay, in a nutshell. And we'll go over in detail about this course syllabus. If you look at the cloud computing, okay, we're gonna cover all these topics, everything from very scratch. Okay? Everything is from very scratch. You do not need to have any prior knowledge. If we have worked on-prem, that's fine. That's all we need, because that's the intention of this course, to get you up to speed on cloud, microservices, containers, and DevOps. That's the intention of this course. And we'll go about cloud computing introduction from very basics. What is cloud computing? Why cloud computing? What is cloud computing? Service models that we use, infrastructure as a service, platform as a service, software as a service. What are these? And what considerations we need to make when are we talking about these service models? What are different mindsets? What are these service models first? What are deployment models? Public, private, hybrid, community. These are the deployment models. Major cloud service provider will understand about. These are the three major cloud service providers that we have: AWS, Azure, and GCP. We'll create an account in AWS account. Everyone will be having a hands-on experience. That's for sure. Okay, and you will be practicing along with me. Everyone will have an account. I'm going to guide you how to create an AWS account, and everyone is going to practice daily. And after completing this, you'll be very much comfortable in cloud. You can speak very confidently in interview. You would feel that you have worked on cloud. Hands-on experience. You're going to get a hands-on experience here. We'll understand how to set up a budget, and we'll talk about AWS regions, what is availability zones, what is IAM, very important service. When I say cloud, I basically mean this. Okay, I have this AWS console here. Everyone is going to have an account like this, and we're going to talk about a lot of services. They have a lot of services here. Cloud is the necessity right now. If you do not know cloud at any cloud service provider, you have to know one. Okay, if you do not know, it's very difficult to survive IT industry, to be honest, because everyone is talking about cloud. Every other organization is using cloud service provider to have their application deployed. Nowadays, people are trying not to use on-prem. Unless you are not a big giant company, you're not going to have your on-prem infrastructure, because that involves cost. And even if you're on-prem, what you do, you can have we're talking about hybrid cloud model nowadays. Just to, even if you are a big company where you can afford to have your on-prem infrastructure, still those companies use cloud for various other activities, for storing. For a backup activity, they use S3. S3 is a storage services we're going to cover. So they still use cloud. So anyway, either you are working on-prem or cloud, you have to know one cloud service provider, and AWS happens to be the most popular one. It captures 33% of the market share, and we're gonna take care of AWS here. And it's not just AWS. Once you understand one cloud service provider, it's very easy to relate other like Azure and GCP, because the core functionality of all cloud service provider is same. Only the name changes, the UI would change. This EC2, they call it EC2 here. The Azure calls it virtual machine, VM. Oracle calls it compute. So it depends on just the name, but the core functionality is the same. You have to know one cloud service provider, and we're gonna take care of that. We're gonna use this, and we're gonna practice everything here. We're gonna practice everything here. If I talk about EC2, I'm gonna show you the load balancer, the auto scaling group. How do we create instances? How do we create volumes? What is AMIs? What are the security group? Because in cloud, security is the most important thing. What is elastic IP? We're going to talk about load balancer and auto scaling group, because in production you do not want auto scaling in place, right? You want your servers to be auto scaled when the more load comes in. That's very important for a performance tester to understand about load balancing and auto scaling group, because you like to configure that automatically based on certain criteria. Let's say CPU utilization. If you observe CPU utilization to be 70% or more than 65 to 70%, you would like to servers to get auto scale. You would like to provision servers automatically to accommodate those extra user load. So we'll understand how do we configure that and test those scenarios. So basically, this is just an introductory session. I cannot cover everything here, but we're gonna cover everything, whatever it's being reflected in this slide. And you can also get this information in the, you have website as well, Isha Training Solutions website. You can go to this link and you can also get an understanding of what all are we going to cover here. Okay. So you can find these demo sessions here as well. This is the last batch demo sessions, June batch demo sessions. You can also go over them, and we can also conduct these demo sessions live, and you can go about the feedback of the people, and then the course syllabus. What will I learn by the end of this course? And then the syllabus. Syllabus of it, everything, cloud computing, we are going to cover everything here. So you can just I'm going to paste this link, and you guys can see this in your free time. Okay, let me just, so that's the, okay, so that's the cloud computing. We'll talk about a lot of other things. CloudWatch, the in-house monitoring solution for performance engineers. Monitoring is the most important thing. If we do not monitor the server utilization, we cannot predict anything. We cannot troubleshoot anything. We're gonna understand AWS CloudWatch. How do we monitor things in cloud, and load balancing auto scaling group. We're gonna talk a lot about these services: SNS, software notification service, Lambda, API gateway, cloud formation. We're gonna talk about all these things. On the second chapter, we're going to talk about Linux command line, and get as comfortable with Linux as you are with Windows. As simple as that. So that's the tagline we believe in. If you are very much new to this Linux world, if you do not know how to navigate to the Linux operating system, how do we? So I would make you think from a Windows user perspective. If in Windows, if I ask you how do you zip a file, you would say I just right click on a file and I just click. I have a WinZip software or 7-zip software. You can use that and compress it, right? But if I ask you to do the same thing in Linux, how would you do that? So I would make you think from a Windows user perspective, and you're gonna do all those activities. What you do in Windows, you're gonna do all those activities in Linux, and that's how you will be comfortable. And it's just an operating system, right? At end of it, if it's just an operating system, you just need to know how to navigate, how to work on the operating system. If I ask you to find a word in a file, you in Windows, you will open a file, you will do Control F, you will put that word. If I ask you to do the same thing in Linux, how would you do that? We'll understand that. If you have thousands of files, if I ask you to search for a word, search for error message in all those 100 files, how would you do that? So we're going to understand, because we are working in Linux. When you talk about microservices, Docker, Kubernetes, you are working in Linux operating system, and you need to be comfortable working in Linux. And that's what the intention of this course, of this chapter, is to get you comfortable. How do you use system information, hardware information? How do you use performance monitoring and statistics? We're gonna provision the EC2 instance that we have. I'm going to create a virtual machine here. I already having. So you're going to create it and you're going to start it. You're going to practice everything hands-on. That's the idea. I'm just starting a server. You will get inside the server and you will start practicing. That's the thing. That's the idea here. And you're going to use Putty here. Putty is the software that we use to get inside. If you are a Mac, the approach would be different. But you have this Putty software, and that's what we will be using to get inside this VM. So you can see that. Okay, let me just grab the public IP. I need to grab the public IP here. Then I can just go inside this guy. And everything would be hands-on here. Okay, everything would be hands-on. Just need to provide this public IP here, and that's all. I'm going to talk about how do we configure the putty and how do we work. So I just logged in. Okay, let me make you guys visible so that you guys can see this. Just okay. I hope this is visible. So right now, if I ask you what this operating system is, so I can in Windows you go to. If I ask you which operating system you're using, you go to my computer. How you go to this computer, my computer, you do a right click, go to properties, and that's how you get to know your operating system and the configuration, right? That's how you get to know. If I ask you to do the same thing in Linux, how would you do that? You can type uname -a to understand the operating system. If I ask you how many CPU you have, you can type ls CPU to understand. Okay, just having one vCPU. If I ask you how much RAM you have, you can type free-h to understand how much disk you have. So it's all about commands, okay? And it's easy. It's not that difficult here. The only thing is that you need to know what to use, what command to use to access what. So you just need to be knowing that, and that's how we'll get comfortable. If you're new to Linux, we'll get comfortable. If you already know, we're going to talk about self-scripting. At end of it, we're going to use self-scripting to understand how do we automate those things using self-scripting. Self-scripting is very important skill set to have. We're gonna let's say if I ask you that I'm running a performance test and I need the statistics of CPU, memory, disk for the entire 1 hour. How would you give me those details? You do not have any commercial tool. How would you do that? So you can achieve that using a shell script. If I use stop command, you see that there is something called load average. We'll understand what is this and what the CPU, how do we use shell scripting to get this information and plot this in a graph. CPU, this is the memory you get and all those processes you have it here. So we're going to understand each and everything. Okay, we're going to get comfortable with Linux. After that, we'll talk about the third chapter would be to go about software application architecture, to understand the microservices architecture, what are microservices, how it differs from monolith applications and things like that. We'll talk about container engine, the Docker. How do we work with Docker? Docker installation, Docker common operations, Docker. How do we build Docker images using Docker file, Docker volumes, Docker compose? How do we run images using Docker compose? What is Docker compose? We'll understand each and everything about Docker, Docker networking, everything. How do containers communicate with each other? Uh, at the end of it, we need to host microservices, and you do it in containers. And you need container engine to create containers. We'll understand how performance engineering fits in DevOps. What's our role? What's our contribution? How can we contribute in DevOps? We'll understand how performance engineering fits in DevOps and the elements of performance engineering approach to software development. Continuous performance testing, a shift left approach, shift right approach. We'll understand that. The most important of all, we'll understand Kubernetes. That's the skill to have. Everyone is asking for Kubernetes, and you need to understand how do we orchestrate. Once you create the containers using container engine, you need an orchestration engine like Kubernetes so that you can do auto scaling, right? You can do load balancing, you can deploy your pods. We'll understand it. If things are overwhelming, don't worry, because that's what we're going to cover. If you are thinking it overwhelming right now, it's good, because you're going to learn all those things, okay? And you will be comfortable, as you will be really comfortable once we cover everything. Yeah, and we'll talk about CloudWatch Container Insights. Once we have all the pods deployed, how do we monitor them? We can also look into Prometheus Grafana, okay, used for the monitoring tool, the HPA, the horizontal pod autoscaler, cluster autoscaler. How do we deploy pods? What is multi-container pods? We'll talk about EKS, basically, Elastic Kubernetes Service. It's the AWS offering of Kubernetes. Kubernetes is a free tool, open source tool, and every cloud service provider has leveraged this, and they have their own service, and they call it managed service. I'll talk about EKS here. It's very much demand skill. If you know EKS, there is no way you'll be highly in demand, to be just to put it straight. EKS is the most important skill set to have, because you don't know just the Kubernetes, but also how AWS has implemented Kubernetes, and they have implemented using EKS. We're going to talk about EKS here, okay, in detail. How do we create cluster and how do we work in the cluster? We're going to understand the horizontal pod autoscaler. How do we make it auto scale, right? The idea is, once your application is deployed in Kubernetes, it is to be highly available, highly reliable. It should not be it should not go down. That's the idea, and that's why it is most popular. It's from Google. You can understand why Google were using Kubernetes. They were using Kubernetes from last 15 years. They have revealed a few years back that they were using it. And that's the key to their success. That's how they have been managing their application workload. And that's why the industry is going, and they're trying to implement Kubernetes in one way or the other. If they have this microservices architecture, they're going to use Kubernetes. And at last, we're going to understand how continuous performance testing works in DevOps, and how can we contribute it as part of performance testers. How can we contribute to this DevOps? Because DevOps applies at the organization level, and we're going to understand how do we create our job, performance job, what plugin do we need, how do we add nodes, how do we configure email notifications, how do we create pipeline, scheduling the pipeline jobs with dependencies. And we're going to also understand the AWS services, which is applicable to CI/CD pipeline. We're going to understand Jenkins integration with DevOps tools like Git and Docker Hub. We're going to understand the Jmeter here. How do we create Jmeter job in the CI/CD pipeline? We'll understand how to create freestyle jobs, automated feedback, because with every job you would get a build log, and the build log has to be and the person who has created the job, he has to know what the job, whether the job passed or failed. So we will send email notification with the build log attached. We'll understand that. So, we're going to talk about Jenkins here. How do we install Jenkins from there? It's from very scratch. We're going to talk about it. Okay. So that's all I wanted. That's the syllabus of it, and that's all I wanted to cover today. Okay, and at last, what will I learn by the end of this course? Okay, that's the very important thing. And just to highlight, all the topics are covered from very scratch. Everything is covered from very scratch, whatever I just mentioned. So if you do not have a prerequisite, it's fine. No need to worry, and things will be taken care. That's how I deal with things. All we need is your enthusiasm to learn. That's all we need. And by the end of this course, you're going to learn a lot of AWS services. You will be very much comfortable working in cloud, and you can very much go and write cloud practitioner and solution architect associate. It will lay a very strong foundation, okay, on the cloud. And after that, I can guide you and what all additional things you need to go over to take care of cloud practitioner and solution architect exam. So I have cleared it, so I can guide you in a better way. But I have taken this course from a performance engineering point of view, what all things are required. They would not ask about a lot of questions about EKS, Jenkins, but we are covering it. This is a performance testing engineering course, but we have it will be a very strong foundation. And once I guide you, you can easily clear cloud practitioner and solution architect exam. Okay. You'll be very much comfortable working with Linux, that's for sure. Microservices, Docker engine, container orchestration engine, Kubernetes, CI/CD pipeline. Yeah, that's all you're gonna learn here. So yeah, so I'll open the floor for the questions. So if you have any questions, please let me know.
Hi, Roshan. This is Arnav. We have a question. Can I go ahead?
Hi. Sure.
Yeah, so you talked about the microservices. So can you just please explain what is the difference between microservices and web services?
Okay. See, microservice, you should think like it's a subset of your application. Okay. So don't get confused between the web services and microservices. They are not on the same boat. Okay, they cannot be compared. Microservices are just nothing but a subset of your application, and the web services is there. You know the web services. It is trying to convert one language to another, right? Microservices is a subset. You cannot compare microservices and web services. It's just a subset of your application. Let's say if you are having one application, let's say if you're having one application, big application, let's say, uh, let me just make it easier for you. If you're having one application, let's say this is your application, and everything, all the logic resides in one server, application server. And you may be having 10 modules here. Okay, 10 modules means you could have your module A for one functionality, you could have your module B, you could have your module C. Okay, then you have multiple modules, right? And they are tightly coupled. In the case of monolith applications, it's tightly coupled. And in the case of microservices, what you do, when I say tightly coupled, means if you're writing the functions here for this module, you're going to call the function anywhere and everywhere. And there is a huge dependency. And with that, and with microservices, I'm just going to break these modules. So module A will be your one microservices, module B will be your another microservices, and module C will be your another microservices. So that's the microservices concept. When I talk about web services and REST API, it's the way you convert the language and interpret it, right? So it's totally different thing, web services and microservices. I hope you understood it.
Yes, thank you.
Sure. Srinivas has asked very vast topics you have shown here. Yes. Are we going to cover all this? Just you are right, Srinivas. We are going to cover this in 40 to 45 hours. That's how we take time. It's a very vast course, as you rightly mentioned. Yes, it's a very vast course, and it takes around. We're gonna meet daily on the weekdays, Monday to Friday, 1 hour, 7:30 to 8:30 a.m. IST, and we're gonna meet for another 2 months to complete this 40 to 45 hours. I need to cover. Yes. We are not
Roshan,
going
this
to
is
rush.
Riva here.
Yeah. Hi, Riva.
Yeah, I just wanted to know from the AWS perspective, like we'll be covering the configuration part of like EC2 instances and IAM services and other services of AWS as well.
Yes. As I have mentioned this in this particular syllabus, okay, if you have noticed, we are talking about IAM here, we're talking about EC2 here. Everything would be hands-on. A VPC, how the networking works here, the database services, the storage services. We're gonna cover everything hands-on here. Yeah.
Okay, thanks. Yeah.
It will be a very see the feedback that I hear from everyone. Yesterday only I have completed one batch. If everyone tells that it's been a very great learning experience, you're gonna learn in the session, okay? Because you're gonna see everything. That's what I do. Uh, uh, and everyone is going to have one account, okay?
Hi,
And you're
Roshan.
gonna
Krishna here.
yeah.
So,
I
do we do any live projects, like at least to get hands-on with any practical project, and that could be our example of how we navigating, how we are doing this performance with any practical project, only learning thing, or any practicals with a live or at least a original project which could be helpful us to understand deeply in terms of the performance cloud using DevOps.
Everything would be practical here. Everything would be practical. Everything would be hands-on, and we're gonna do everything what is required in the industry. To answer your question, yes, everything would be practical and everything would be hands-on. We're gonna have our own server, web servers. We're gonna when we talk about load balancing and auto scaling group, you will have it just not the theoretical part, but you're gonna understand how this load balancing working. We will have our applications, the web servers, and we'll understand this load is getting how the load is getting balanced. It's a round robin or it's a or other algorithm it is following. We're gonna see everything hands-on. When I talk about the Docker Compose, you will have the real application, the MySQL, the database, the app server, the web server deployed. You're going to have everything hands-on. It's a real time what we work in our project. So that's how the intention is, and everything would be hands-on and like the way you work in the company. Yeah.
Any
Yeah,
session
thank
on
you.
LoadRunner integration with CI/CD tools like Jenkins?
Correct. CI/CD pipeline. We're gonna cover CI/CD pipeline using Jenkins, and Jenkins is a CI tool. We're gonna cover that CI Jenkins, and we're gonna create our job, our CI/CD automated CI/CD pipeline. You will understand the in and out of the CI/CD pipeline, how you integrate your Jenkins with GitHub, how the pipeline would be automatically triggered. When I say automatically triggered, basically you will have this is a snapshot I have taken from one of the sessions, and that's how this is the pipeline we're going to create. Because once the developer uh, pushes its code to the GitHub, all your jobs would get automatically triggered one after the other. We're gonna create. I'm just going to update something on the GitHub from the server remotely from Git commands, and you would see your pipeline you're getting triggered. Your Jmeter job would be running. It is giving you statistics running in the background, and you will get the output. You will get the email notification as well, whether your Jmeter test has passed or failed. And based on that, your code will be pushed to production. And that's the automation, and that's the DevOps core fundamental thing is you want to uh, make the deployment swift, that want to make the deployment speed, the release swift. That's the idea of CI/CD pipeline. Everything is automated, and you achieve that by automating all the processes, all the jobs, and that's what we're going to understand. How do we do that?
Okay, thanks, Roshan.
So,
When the classes are going to start tomorrow?
okay, we're gonna yes, it will be continuing. So today was our first session, and it will be continuing from tomorrow. There will be a few demonstrations and plan. Yes, it's today 10th August, right? Yes, and we're gonna continue from today.
Great.
Yeah, so it will be tomorrow, day after tomorrow. It will be continuing now. We're not going to. So that's we have
Is it
started
for
with
the
our
same time?
class. Yeah,
What will be the
7:30,
timing of the course?
7:30
Okay.
to 8:30. 7:30
Okay.
a.m. to 8:30 IST, and for US participants it will be 10 p.m. to 11 p.m. and for UK, the odd timing, but that's the timing. You can go over this link, okay? You can go over this.
Any programming language which will be useful for the AWS thing, like Python could be trained here, only any programming language?
We are not covering programming language here, okay? Programming language itself takes 20 to 30 hours, okay? We cannot cover programming language here, but I can guide you what path you would like to take up. If you want to go with performance engineering field, I would suggest Java. If you would like to shift your career to DevOps or SRE, I would suggest Python. With self-scripting is a must.
Yeah, I
Self-scripting,
would like to go for DevOps engineering support.
right.
Yeah.
So this will be a very useful course. This will be a very useful course. Either you want to pursue your career in performance engineering, Java performance engineering, in cloud, or in DevOps. In DevOps, I can guide you with the next steps what you should do. Python, Ansible, and Terraform you need to understand. I can guide you on that as well. But this will be a very good starting point for you.
Okay, thank you.
Roshan, I have a question here. So I am a 3.5 years experienced performance tester. So I actually want to take AWS very seriously and want to do a certification, associate level certification
Right.
for AWS. So which one would be useful for me more, the solution architect or the developer?
Where do you want? What's your goal? What's your ambition? What's your aspirations?
My ambition is to move into this performance engineering domain and to work on this.
Yeah, the solution architect would fit you better. So SAA, solution architect. So this will be a very good learning point for you because you will understand the cloud as well as the performance engineering concepts which you're gonna like employ in your organization, like Kubernetes and other things. And I'm gonna guide you as well because we're gonna cover a lot of them. So I would say 60% you are almost done with your solution architect. Once I go over all the cloud concepts, 60% you are done. I can guide you further as for you to write your SSA exam. Yeah.
All right.
Okay. So looks like we are top of our hour. So let's respect that. Okay, so thank you everyone for joining. Hope to see you soon. Tomorrow we can meet. Okay, and if you like to go over the demo sessions, what we usually do, you can go over these recordings here. But again, you can join me tomorrow as well for the next demo session. So thank you everyone for joining. This recording will be shared to you and everyone. Thank you.